Let's understand next about nuclear force. Having gone into details of properties of nucleus, that is its size, its charge, its nuclear spin and nuclear quantum states, and also after understanding that nucleus is a quantum system, let's move into the one of the fundamental forces, and it is nuclear force. Now it is a nuclear force which is responsible for stability of nucleus. Now we know that in nucleus we have neutrons and protons. Protons are positively charged particles and neutrons are neutral, so there is a repulsion among positively charged particles called proton. Now if we just consider this way, then it is a very unstable picture of nucleus, and that means the protons should fly apart, thereby breaking the nucleus and destroying it. But it doesn't happen in reality. The fact is, yes, there is a nucleus, it does exist. It means there must be a stronger force which is putting all these repelling protons together, and this force is simply referred as nuclear force, which binds all nucleons together in an entity called nucleus. Now we know that there are four fundamental forces found in nature. The first being gravitational interaction or simply gravitational force. Then we have electromagnetic interaction or electromagnetic force. Then we have nuclear interaction or nuclear force, and the fourth one is the weak force or the weak interaction. Now out of these four fundamental forces found in nature, nuclear force is the strongest force and gravitational force is the weakest. In fact, if we put it into sequence of increasing strength, we will have gravitational force as the weakest, then slightly higher it is weak force, and then a stronger force, that is electromagnetic force, and then we have the strongest, which is the fourth one, and it is the nuclear force. Now let's understand the properties of nuclear force which are observed in nucleus. So we take up many properties. Let's go one by one about these properties and let's understand them, and that is very important and fundamental for understanding nuclear physics. The first property says that nuclear forces are attractive in nature. The magnitude which depends upon the nucleon distance is of very high order. Again, so let's elaborate this. Nuclear forces are attractive in nature in general, and the expression for nuclear force is very complicated. It is not similar to or simpler like the expression for gravitational force or the electrostatic force. In fact, when the distances are very close, the nature of nuclear forces changes, it becomes repulsive also. So in general, nuclear forces are attractive in nature, but for a very small nucleon separation, when nucleons are very close, it becomes repulsive as well. The second property says the nuclear forces are charge independent. That is, nuclear force between two nucleons doesn't depend on charge and mass. Now nature of force remains the same whether we consider two protons or two neutrons or a proton and a neutron. That is, the nuclear force between proton and proton is same as between neutron and neutron and is same as between proton and neutron. Nuclear forces are charge independent and mass independent. Now the third property says that these are short range forces. Nuclear forces operate between two nucleons suitably situated, and it is in the close neighborhood only. Now this is the property of nuclear force, that is, they are short range forces, and outside nucleus the value of nuclear force is almost negligible. So they are operative and dominant in nuclear range only. The fourth property says nuclear forces decreases very quickly with the distance between two nucleons. The rate of decrease is much rapid than that of inverse square law forces. The forces become negligible when the nucleons are more than 10 to the power minus 12 centimeter apart. The next property says that nuclear forces are spin dependent. This is a very important property. Nuclear forces are spin dependent. It means nucleons having parallel spin are more strongly bound to each other than those having anti-parallel spin. The sixth property says that nuclear force doesn't obey principle of superposition like gravitational force or electrostatic force. The seventh property says when the distance between nucleons becomes less than 0.5 Fermi, the nuclear force becomes strongly repulsive. As I told in the very first point, in general nuclear forces are attractive, but when the separation is very close, that is less than 0.5 Fermi, the nuclear force becomes strongly repulsive. Then we have eighth property, and that says the nuclear force show saturation properties, that is each nucleon interacts with immediate neighbors only rather than with all other nucleons in the nucleus. This saturation property is very important. Take a note of it. Each nucleon interacts with its immediate neighbors only rather than all other nucleons in the nucleus. And the last property, that is nuclear forces are non-central forces, and this shows the distribution of nucleons in nucleus is not spherically symmetric. Now, having gone through 9 properties related with nuclear force,